Alright guys, welcome to Codeoff, and today we will be solving the Petya and countryside problem. So actually this problem is from the ACM ICPC problem sheet. It's a really great sheet, and those who have does not have a plan on which where to solve, how to solve or the Codeforces problems, so you should guys check out that sheet, because the problems are sorted and it's sorted in a difficulty manner. So first you solve the A problems. There is a list of A problems and list of B problems too, and up to D and E problems. So make sure you check out that sheet, because it's a really great sheet to solve in order wise problems. So, and the video solution of all those problems is in Arabic language, so I thought maybe I should make that in English too, because it would be accessible to all these all of the users. So let's see what the given problem states is. The given problem states that we are given a 1 cross n size garden, and we want to create a artificial rain over over one of the section, such that all the section will have the maximum rain. So for example, if we create artificial rain over this section, that is 3 height of section, then the how many sections will have the water collected. So 2 will have a collection of water, this 3 will have a collection of water, this 3 will have a collection of water, and the right side 2 will also have the collection of water. Now the problem states that we want to find the maximum collection of water over maximum water should be collected over maximum sections. Okay, so if suppose we create an artificial rain over a height of 4, then the water will only be cluttered in height of 4 and height of 2. It will not be in height of 3 and height of in the right side. So the number of sections which will receive the water is only 2. So it's not a maximum section. So what we need to find is the where we could how many maximum sections we could create, we could flow the water. So let's see with an example. So let's say we are having 1 2 1 2 1. Okay, so what we will do is we will draw a 1 and a 2 and a 1 and again a 2 and 1. So let's suppose this is an artificial garden, and we want to find how many sections will have the maximum how many maximum sections will have the water. Okay, so let's see, if we create an artificial rain over this, then it will only have one section. That is because now this height, its right height is maximum, so only this section will have the water, so that's 1. Now if we create over this section, then the water will be in at this height, at this height, and at this height, so that goes to 3 section, so which is maximum than 1. If we create this, it will still be 1, so that's not maximum. If we create this, then it will be this height, and this height, that is again 3, and if we create here, it will be 1. So as you can see, the artificial rain which will be in only 3 sections, maximum of 3 sections, if we create an artificial rain. So the approach to the given problem is kind of a brute force. So what we need to do is we need to traverse the whole sections, and we need to check its left and its right. Means we want to check how till what point towards the left is our height is minimum. So for example, if we are here in this section, then till how much point is our height is minimum, that is it does not exceed a certain point. So for example, if we saw here, it will be 2 sections and here 1 section, right? So we got over 3 sections of cluttered water. Okay, so if we get another example, we will clear the problem much. So let's see, we got 1, we got 2, and 3 ones. Okay, so we got another 1, and another 1, and we got a 3 and a 3 and a 4. Okay, cool. So what we need to do is we need to check now here we need to check how many maximum sections we could create, means flow the water. Okay, so for example, if we create here, it will be only one. If we create here, so what was our approach? We will check from the current state towards the left and towards the right how many sections water can be water can be cluttered. So if we check to the left, only this section can be cluttered, and if we check to the right, only this, this and this. Now here the height of the height is maximum than the current height, so we cannot create a water will not flow here. So the number of sections right now is 1, 2, 3, 4 and 5. But if we check, let's see, if we create an artificial rain over here, so what will happen is the rain will be cluttered in here, this section, this section, this section, 3, 4, 5 and 6. So in total there are 3 sections. In total there are 6 sections where the artificial rain will be water will be cluttered. So maximum is 6. So as you can see, the approach was that from the current point we will check on the left side and on the right side. So it's kind of a binary search. So yeah, so this is the problem, and let's see now. Let's see the code now. Okay, so what the code states is we will take an input, but after that we will traverse to the whole array, and we have an answer variable, and what we will do is from the current point we will traverse to the left. So we will check until our point is less than the current next point. So for example, if we are here, so until our as this is less than the left top side, so we will check we will check that. So v of j should be greater than equal to v of j minus 1. Until that we will loop through the whole while loop, and as soon as we reach a point where v of j is less than v of j minus 1, as you can see here, so we will will break through the loop, and then in the next while loop we will check how we should be less than the right side, right? So for example, if we are at this section, so how many sections are there till our height is minimum? So it's this, and it's at this point our right side height is maximum than our current height. So that means we need to break out of the loop. So this will create a this will search for right side, and this will search for left side. So yeah, so this is the problem, and we will update our max. That is if what's the we will just update the maximum height. So that's it. This was the problem for Codeforces B, and this problem you guys should check out the problem sheet. Actually it has a really great problems, and I will update I will give that in the description box. So make sure to like, share and follow guys. Cheers.